Well, I would like to welcome you to this afternoon session. And first of all, I'd like to welcome Richard Andrew. I actually met Richard. He was actually referred to me when I was in Australia. And we set up a Zoom, and I realised very quickly that we had some interesting discussions in common. And then I followed him when I came back to New Zealand. And Richard's doing a lot of work on LinkedIn. And I really found that quite a few of his blogs and the articles that he was writing were really very forward thinking. And all of you know that I'm very much a literacy person, although numeracy and the students at risk with numeracy is also quite dear to my heart. But I started following Richard on his LinkedIn and looking at some of the articles. And more recently, he's actually broadened his work into leadership in schools and how leadership and change actually happens. And as soon as I saw that, I thought we've got to have him on the leadership forum because he's going to bring such an interesting discussion. So before I hand over to Richard, what I'd like to remind you of, we've got some giveaways this afternoon. And the usual drill, if you put your name and email address in the chat, there'll be a couple of draws at the end, and you never know what you might win. So I recommend to do that now. So welcome, Richard. It's absolutely great to have you. And thank you very much for making the time to come along this afternoon.
It's an absolute pleasure. I'm glad to be here. So I need to get this out of the way. I am an Australian. I do come from over there, but I don't believe in underarm bowling and cricket. And we moved over here 10 years ago from a small move from Sydney to Rangiora in the South Island. So and very happily situated here. So that's the background.
Yes. And you do a lot of work in international schools as well, don't you?
My focus used to be with New South Wales, and if you know anything about New South Wales, it's pretty conservative, and for various reasons, I've always been eyeing off the international market because I knew that the way I work would work in well with international schools, but I didn't really know how to access that. And then I caught up. I connected with the mathematics director at Wellington College International in China, who is one of the most switched on mathematics educators I've come across. And so we've put a few things together. She's been great for me and vice versa. So that was sort of my in, I guess.
One of the great places to start, I think, is that you talk quite a lot about student agency. And perhaps you can start by telling us, why do you feel this is such an important topic in maths?
Well, not just in mathematics, but I don't know what the general feeling is in this group, but in my experience, the maths department is often the thorn in the leader's side in terms of trying to implement change, because there's all sorts of reasons why, they are sometimes a bit more resistive. I look at the way I started teaching. To me, I try to operate from a common sense point of view, and the common sense aspect to student agency is, if I'm a teacher and I've got a class of students and they're not taking any responsibility for their work, for their learning, then my role as a teacher is so much more difficult than it needs to be. And their role of learning is so much more difficult than it needs to be. And I'm not blaming teachers here, because I think it's all about awareness. And it took, like in my early stages of teaching, I was doing everything I could to engage my students and have them on my side. And looking back, I realized most of what I was doing in the classroom was the antithesis of what I needed to do to foster agency and engagement in students. But I didn't know that. And I was just simply teaching the way I'd been taught for 12 years. I didn't have anyone around me doing anything different, but I knew that what I was doing was rubbish. And I don't know why I realized that as a first year out teacher, because a lot of teachers, I don't think do get that sort of revelation. They're kind of happy with the status quo. And so I like to talk about what's it to teachers, what's your default approach? And does it foster passive learning or active learning? And starting with those sorts of questions, it can be quite revealing, because there's a lot we can do that doesn't involve throwing the baby out with the bathwater, that fosters agency in students. But yeah, that's a long rant, but I just think it's arguably one of the most important aims that we should have in education, is to have students with agency, engaged, understanding what they're doing and taking responsibility.
One of the things I loved about what you said is, I'm quoting your words here, I realized I was rubbish. It actually takes a sense of courage to actually say that, and to question our teaching practice and being reflective teachers. And I thank you for being transparent and actually acknowledging that. And I think all of us would have some aspects. We all have our good and bad lessons, but we also realize that there are some good aspects to what we do, and there are some others that are not.
Yeah. But
thank you for doing that straight away.
Yeah, I don't know. I don't know why a lot of people find that difficult, but I have this memory as clear as day. I was in country South Australia teaching. It was a year 8 class, which was the first year of high school back then. And I remember this student, I think we were talking fractions or something, and he just wanted to understand why. But why do you do that? And I had no idea how to answer his question. And all I could do was give him another example. And I walked out of that, and it was like an epiphany moment, but it wasn't an epiphany of, it was an epiphany question. And I walked out thinking, what I'm doing is rubbish. I don't know any better. Someone somewhere on the planet must know how to teach this thing called maths well. Someone must know, but I don't know anyone who does. And this is ridiculous. And it was interesting. I never really thought about it then, but 5, 6, 7 years later, I find myself, really absorbed in this journey of trying to work out or make sense of this thing called mathematics education.
And last time we spoke, you talked about the elephant in the room. Tell us a bit more about how you see the elephant in the room and how we can address some of these things.
Well, look, there's a risk of overgeneralizing. And so, I'll preface that because I do make some general statements, because there's awesome things happening in mathematics classrooms and in all classrooms. And there are some schools that are better than others, and so on and so on and so on. But my point is that if we could get in, hypothetical, right? If we could get inside the heads of every student studying mathematics across, pick a country, in New Zealand, Australia, UK, US, whatever, and somehow observe that child's, understanding, engagement with the subject, we would find pretty quickly that most kids, a majority of them, don't really have a clue what is going on. Like, they don't understand the mathematics. In other words, they're learning these procedures, but they don't understand the concepts that underpin them. And the reason I know this is true, it's not research. What it is, I call it the unintended mathematics survey. So if you become a maths teacher, then you are part of this unintended survey. And what happens is, when you're at a barbecue or a dinner party or a social event somewhere, and people find out that you're a maths teacher or involved in mathematics education, everyone comes out of the woodwork and tells you their experience of school maths. The engineers say, I love maths at school, it's fantastic, and I became an engineer, right? But most people say, I sucked at maths, I was hopeless, I hated it, blah, blah, blah. And what are they talking about? They're talking about fractions, decimals, percentages, two-step equations, anything with a formula in it, basic junior school mathematics, junior high school mathematics. And I say it's about 70%, but when I put that to maths teachers, they say, no, it's higher than that. It's more like 75, 80. Now, I would argue that the same thing, I would argue that the kids today in 10, 20 years' time are going to be telling, as adults, telling maths educators at the barbecues and social events that they struggled with maths at school. They didn't get it. And that's not, and the sad thing is that maths teachers are trying their hearts out to teach as well as they can. So that's the elephant in the room, because I think, and I guess I've only really become aware of this fully since I've left the classroom, where you've got more time to think about it. But you know, I think we sort of accept that situation. Oh, well, a lot of kids don't get it.
Yeah. Well, seeing we're being very candid here and being very honest, I was one of those students who actually didn't get maths at all. When we came out from England, I had to have special maths lessons with the principal because we had a new curriculum, a different curriculum. But so I've actually been fascinated in the subject of why so many people don't feel confident with maths and why they can't do it. And I read a book by T&T Miles. It was called Dyslexia and Mathematics. And they had some very enlightening things to say, which I'd like to share with the audience and also with you. And I'm going to invite you to comment, Richard. But they talked about inchworms and grasshoppers. Now, inchworms often a very procedure and step-by-step methodical way of doing mathematics. And grasshoppers, they have poor short-term and working memory. They can't hold numbers in their head. So they actually have to find a system to make it work. Now, for example, if you are an inchworm, you would take an algorithm like 297 minus 47, and you would do it in your head just like an algorithm. Now, actually, the number was something like 197 plus 103. Now, because I haven't got the working memory, I actually round numbers down and then round numbers up again. And I get an answer by working the method. Now, very interestingly, what these two researchers found, Bath and Knox, was that most of the people who have difficulty with maths are grasshoppers. And the ones who say they're good at maths are inchworms. And what they also found out was that most of the maths teachers are inchworms, and they think us grasshoppers are idiots. And so we end up not feeling very confident about maths, which is interesting, even with what you're talking about the percentages. So what's your take on the inchworms and grasshopper idea?
Yeah, well, I think it's a good analogy. You know, that elitism in maths is alive and well, but it's usually unspoken. Like I don't, and it's possibly, well, I would say it's probably mostly unconscious. You know, that there's an elitist attitude in a lot of maths teachers that, you know, well, we're a bit better, and let's face it, it's not for most kids. It's, you know, this elite sort of subject, and I was always good at it, and you know, I'll do my reasonable best with what I can do, but I know that a lot of kids aren't going to get it, and I know that I teach it well, and if they're not putting in, well, it's not my fault, which is kind of a sad state. And I'm not suggesting that we can get every student on board, because there's so many other, as we all know, there's so many other factors involved, but there are lots of things we can do, which we'll get to, no doubt. But the irony is that, and this is part of the elephant in the room, if I'm a maths teacher and I've never struggled at school, right? Maybe a couple of lessons I was pretty puzzled and a bit disenchanted, but basically for 12 years at school, I was fine. And if I'm not thinking about this, how do I relate to 70 to 80% of kids who are the grasshoppers, who don't get it and who are tortured by this subject where they don't understand what they're doing? So mathematics lessons, okay, this is a memory game. I just have to remember these 352 procedures and somehow assemble them in the right order and recall the right ones at the right time, even though I have no idea what they mean. And that's I can't do it, but I've got to do it anyway because they tell me I have to do maths. How does a maths teacher who's never thought about this and never experienced that empathize with those kids? I don't think they can.
I've actually had this discussion with quite a few maths teachers, and they are really surprised about the whole idea, but they're actually thankful for actually knowing.
Again, see, awareness is such a key thing here.
Yes.
And that's why you said to me in the pre-chat, you know, you like the way I make people think. And I guess that's my number one reason for writing anything or creating a video, is to make people think. And I kind of know the areas of, you know, the maths or education where there are elephants, that because people are not really thinking about it. And I know what it's like as a classroom teacher. I never had any brain space to think about anything. It's the busiest occupation ever, isn't it, known to mankind. It's insane. Anyway, but so that's a part of the reason. So some of the elitism is tied in with that as well, because, you know, I'm a teacher. I'm not thinking. I don't even realize the nightmare that 70% of my kids are experiencing, because I don't even know that it exists. And so over the last 15 years, I just build up this unconscious thought that is elitism. It's, well, a lot of kids just can't do it, and that's just the way it is. I'll do my best and see what happens, and you focus on the better students, and, you know, away we go.
So perhaps you could share with us some of the concepts that you want to bring in. And I know you've got some demonstrations. You were talking about sort of the traditional approach being the procedure first and understanding second. Okay.
Right. Yeah. So before I get into this, can I say I've been this is an unusual journey for me, I guess. Like most people in my position would have gone to uni, done a PhD, and you know, or they've jumped on the research of someone else. And we could talk about research, the pitfalls of the research paradigm. I'm not saying we shouldn't do research, but that's a whole other topic. But so I knew it wasn't working initially, and I was also, I had about a 10-year nomadic phase after 6 years of teaching, which allowed me to do a lot of casual teaching and a lot of maths tuition. And that's when I saw the same problems over and over again. These kids have no idea what they're doing. And so in the tuition, I'm exploring these ideas. And then I had 2 small school experiences where I was the maths department. So I never had people above me saying, you can't do that. You got to teach, you know, you got to teach this way, the same as everyone else. And so that allowed me to develop things. And I did discover some things, and then found out that they weren't new discoveries because other people had discovered them, because I was reading other research and putting it all together. So that's kind of my journey. And I used to use terms like a conceptual approach to teaching mathematics, or a procedural approach. And I've stopped using those because they are so loaded with, I mean, the maths wars that have been going on in America for decades are all about procedural versus conceptual, which is the most insane argument, because nobody teaches 100% procedurally or 100% conceptually anyway. So I don't even know what the argument's about. But anyway, I've dropped those terms because they're too loaded. And so to explain this very simply, right, if I look back to how I started teaching, and this is the way I present it to teachers, because I know that most teachers still teach this way, but if I bring it to myself and say, well, this is how I taught for the first few years. I'm a teacher of mathematics, therefore I teach procedures. That's what's in my head when I'm going into a classroom. I've got to teach these next 3 or 4 or 5 procedures. And if I do it well, and I get the students to practice enough, hopefully they'll understand the maths. But I didn't know what that meant. And I knew that a lot of kids wouldn't understand it anyway, but that's all I knew. So I'm a teacher of procedures. So that's procedures first, understanding second. So I'm focusing on procedures, and I hope the understanding follows. And so what I'm talking about now is a flip around of that. I'm saying, because before, when I talk about a conceptual approach, teachers would say, oh, so Richard, you don't believe we should teach procedures? No, I never said that. So this is why I now use an understanding first, procedures second approach, because it kind of makes sense. So what all it is a mind shift. So now I walk into a classroom and my number one aim is to have students understand first, and then we can look at the procedures. But what do I want them to understand? Well, let's be specific. If I'm going to look at this procedure next, like say the division of fractions, I want them to grapple with the concept that underpins the division of fractions. And that can simply be like a little worksheet, something they work together, but it's anything that that doesn't have a procedure attached to it. So they're not just following a routine, but that gets them to think and grapple with the concepts and maybe draw something on a page and whatever. And it might be just a 5 or 10 minute activity. And then you go into the procedure of it, and it makes sense. And then you start with questions that they can do kind of in their head because they're thinking conceptually about it. And then you go on to the ones that are kind of more arduous because there's lots of more cranking out numbers and all that sort of thing. So that's just one example. So it's an understanding first, procedures second, rather than a procedures first, I hope the understanding follows. So that's kind of that's the underlying approach that's how I explain the approach that we're advocating with maths teachers. Did that answer your question? I think it only partly answered it.
It did, but that also fits in very nicely with what these two researchers, Bath and Knox, found. And they said that we actually have to have multiple styles of teaching maths. They actually recommended that you have an inchworm introduction. In the middle of the lesson, you do a grasshopper approach, and then you follow it up with an inchworm review. And by understanding this, that the inchworms had to be more like grasshoppers, and the grasshoppers had to be more like inchworms. Whereas what we tend to have is people on the conceptual each end of the scale, and never the twain shall meet. And that was primarily what you've described.
Can I mention something about explicit instruction? Because that's kind of tied into your inchworm thing, really, isn't it?
It is, yes.
And this is a bit of a bugbear of mine, because of course explicit instruction is important in anything, not just mathematics. But what my beef is actually, I've got to pull this back one step. So I'm a great advocate for active learning, right? Like, let's look, what can I tweak about my approach so that I'm fostering less passive learning in the classroom and more active learning? Why? Because if the student's active, and in order to foster active learning, it simply means that students need to have a sense of control over what they're doing. In other words, there's some choice there. They're making decisions. They are actually thinking their way through, rather than in the procedures first framework, they're just replicating whatever the teacher does. So there's low cognitive load, but there's no chance for them to take ownership over the activity or the learning if they are just replicating whatever the teacher tells them to do, or just copying notes or whatever it is, right? It's only when there's a sense of control over the learning. And I think this is a really big deal, because it's the easiest way to engage students. And I think a lot of teachers don't realize that point, especially mathematics teachers. Because most maths teachers will say, oh, Richard, this looks great in theory. I see what you're doing, but I can't do that because I don't have enough time. And that's why I teach the way I teach, because the only way they know how to get through the curriculum, which is ridiculously packed, jam-packed with content, is to teach step by step, to do the to do that whole, here's the procedure, copy it down, do 10, here's the next one, etc. Not that any teacher only does that, but I'm just saying that that's the reaction. And yet this understanding first, procedure second model that I and Anya Mori and China advocate, and look, we're not the only ones that do it. There's a lot of other versions of this, but if it's done well, it's more time efficient, right?
You've got some examples there to give us too, haven't you, on fractions?
I will, but I haven't got. This is all this stuff is very difficult to explain in a way that the listener actually gets the message that's intended. And sometimes I lose my track. Explicit instruction, right? So if I am, one of the ways I can tweak my conservative approach is to make it a little bit more student-centered, right? So, and that's, or another way of saying that is, if I'm going to present mathematics in a way where the learning is active, it is by nature student-centered, because the whole point about student-centeredness is it gives students a sense of control over what they're doing. And it doesn't mean a Montessori type approach. Nothing wrong with Montessori. I think it's great, but it doesn't fit in a conventional school. But let's make it a bit more student-centered. Let's give students a bit more of a sense of control, right? Right, so now I want to talk about explicit instruction, because that tied in with your inchworm thing. So there's a lot of PD and a lot of noise that says explicit instruction is really important. It's all about explicit instruction, and I agree. If I'm a teacher and I'm going to give an instruction, it would make sense to make it explicit. Okay, let's not make it vague. So it's not a big deal, and it's pretty obvious. But I don't think the presenters who are advocating some kind of approach that's based on explicit instruction are talking about whether, like, are comparing a teacher-centric model to a student-centric model. They're not talking about student agency. They're not talking about, can explicit instruction be, does it have to be teacher-centered or student-centered? How does that work? That's completely left out. It's just, we've got research to say explicit instruction essentially works well. So my assumption is that the students will do better in the test in 2 weeks' time. My point is that explicit instruction and student-centered learning go beautifully, but it's different. So rather than, and sorry, I'm trying to do two things at once here. The takeaways that I think a lot of teachers take away from explicit instruction courses, the assumption is, okay, so I should do a stand and deliver type teaching. We're talking about stand and deliver. We're talking about teacher centricity. That's the inference, because it's not talked about. It's just obvious that that's what it must mean. Whereas what I'm saying is, if we have a highly structured setup that's more student centric, then you've got students with different needs at different times, and your explicit instruction occurs more organically when a group of students need it.
Right.
And when they need it, and it can simply be, Mr. Andrew, can you help us with this? Now, that's a minor thing, but having kids say, Mr. Andrew, can you show us this, is infinitely better than me saying, right, everyone stop, because Mr. Andrew now knows it's time for you all to get the next bit of instruction. And here we go, pens down. George, listen to me. Shirley, come on, because they're not ready for it, or they don't need it. But I'm stopping everyone, right? And that's my beef with too much teacher-centric, sage on the stage, everyone listen to me. Sometimes you're going to do that, of course. But if you can weave the explicit instructions in with your student-centered approach, which has kids at different levels at different times, then what you can do, like Johnny asks some help, right? Right, everyone stop just for a second. Johnny's asked me this question. Who else needs to know this? Or sometimes I'd say, Johnny's just asked this. Who knows that they know this? Who knows they don't need to hear this again, right? Okay, you 7 people, you can work ahead. The rest of you eyes this way, and then away we go. So that now we're doing a lot more of what I call mini lessons, which is not rocket science, but it's just the way of handling the situation where the students are directing when the explicit instructions should come, and it's like to still, the popular term, it's just-in-time teaching. So I just think it's tragic that explicit instruction is rarely ever talked about in those terms. I could be wrong. I don't know. I haven't sat through many. I've just seen YouTube clips and stuff because of that sort of mode of delivery, and I never hear anything about the teacher centricity or student centricity, student agency, what's better, I just don't think that's part of the discussion. So anyway,
I think you're right in maths. I think that there was there would be explicit teaching would be different in literacy than it is in maths. And I think you've got a very real take on it.
Okay, so well, let's put this to the group. Because what else did you want to? I'm not sure. We've got notes here. We're cheating. We've got some. We prepared this. We've come prepared. I've got. Okay. For ages, I'd wanted to kind of, because remember, I'm working with mathematics teachers, and there's blind spots, and we've already talked about how a lot of mathematics teachers, for no fault of their own, don't really understand what it's like to not understand the maths because they haven't had that experience. And so I wanted to create a video demonstration of what it's like for a student to work through some mathematics where they don't understand. And I used fractions, decimals, and percentages as an example because I think fractions, decimals, and percentage is the first, and I call it one topic because it should be one topic, even though it's taught as three, and teaching, and that's a whole nother thing. Like compartmentalizing those three things into three different topics just makes the learning so much more difficult than it needs to be. But that's a whole nother discussion. So anyway, so that was my example. So I've got these little two-minute videos where I'm a student who doesn't really understand it, but I'm trying to answer these questions. And so I'm just talking through how to do it. Is that with it? Rather me?
I think that would be, I think that would be great because it gives us something real to hang on to. Yeah.
So I don't know how good you people are with basic fractions, decimals, and percentages, but you're going to step in the shoes of a student, as I did. So you hear that 3/4 is 75%, but you have no idea why, right? 0.2 is apparently 1/5, and it's apparently 20%, but you don't know why that is either. When you add fractions, there's all this palaver you've got to do if the denominators are different, and you can kind of do that, but you've got no idea why you're doing what you're doing. All right, so all those basic understandings that underpin fractions, decimals, and percentage, you haven't got them, but you kind of get some questions right just because you've learnt the procedure, or you practiced it last week. But if you stretch it out 2 or 3 weeks, you're gone. So that's where we're at. And let's see if I can replicate. We did practice this because I'm going to share my screen and I'm going to video. All right. Here we go. Can everyone see that? You should be able to see and hear this. Here we go. Starting top left. We need to learn how to simplify fractions. To do that, we find common factors in the numerator and the denominator. In this case, the common factor is 7. We divide 7 into each, and that's why we end up with 3/4. This next one is an improper fraction because the numerator is bigger than the denominator. In order to deal with this, we divide the denominator into the numerator, and in this case, that gives us 4 with 1 left over, and that 1 left over is fifths because the denominator does not change. So we've got 4 and 1/5. In order to convert a mixed number to an improper fraction, we multiply the whole number by the denominator and then add the numerator to get the new numerator, and the denominator stays the same. And so that's why we've got 17/3. When we're adding fractions with common denominators, all we have to do is add the numerators, and that's why this one is 3/7. To add fractions with different denominators, we need to find a common denominator. In order to do that, we need to find the lowest common multiple of the 2 denominators, or 3 denominators if there's a third. The trick is to start with the biggest one and count up in that number. So we're going to start with 5 and count up in 5s, and when we hit a multiple of 2, then we know we're there. So 5, nope, 10, yes, 10 is it, because both 5 and 2 divide into 10. Then we need to convert each numerator by finding out how much each denominator has been multiplied by to get the new denominator. So in this case, we've got to multiply by 2 here and by 5 there, and we do the same to each numerator, and that's why we end up with 4 plus 5, and that's why we end up with 9/10. When we multiply fractions, we simply multiply the numerators to get the new numerator and the denominators to get the new denominator. But it is a good idea to cancel first. And that's why when we cancel 2's into 2 and 4 and 3's into 3 and 3, we end up with 1/2. When we divide a fraction by a fraction, we invert and multiply. So we invert the second fraction and change the division sign to a multiplication sign. So this becomes 1/2 multiplied by 4/3. Then we cancel down appropriately, and that's why we end up with 2/3. Now the reason there was another equal sign is because we could have done the cancellation at the second stage. We could have made this 4, 1 times 4 is 4, 2 3s is 6, and cancelled 4/6 down to 2/3, but because we cancelled first, we don't need that step at the bottom. Now hopefully you saw how much of a nightmare those routines are for students to remember when they don't understand. And there are so many of them. The denominator doesn't change. You divide the denominator into the numerator, you find common factors, you find common multiples, you invert and multiply. So yeah, so that one, that wasn't me as a student, sorry, but that was just to try to show you all the intricate, or not all of them, but a number of the intricate, tedious aspects, procedures, call them what you like, that students have to remember if they don't understand the principles.
Yes. And I was just going to say, confirm there that students with learning difficulties have both short-term and working memory difficulties, and they also have processing delays. And so to keep up with the pace of the class, whereas often if it's just slowed down, and that's when you were talking about the group, who here needs this and letting the others move forward, that's so beneficial, because those with processing delays can then take the time and work more slowly.
But here's the other thing, like every kind of fractions / decimal / percentages type unit I've seen tends to, I mean, other than having a little bit of conceptual kind of picture type stuff in the beginning, that it dives straight into these cranking out the number, like working with the numbers in tedious ways, and one at a time. So it's all compartmentalized. And I don't think, like this thing here, can you see the cursor on the screen or not?
Yes.
Right.
Yes.
So changing improper fraction to a mixed number, well, you can do, like, why not get the students to make up questions? Right? Like an open-ended question is gold, because there's no procedure to follow. The only way students can answer an open-ended question is if they understand the concept, and that's why they're so beautiful, because then you find out quickly which kids are lost. And if they're lost, it's they don't understand the concept. So then you can sort of plug that concept and then put them in their way. You can have kids make up, come up with pairs of fractions that are equivalent, right? So that you're focusing on the understanding, and then do these sorts of things towards the end. But so this is a classic example of what's involved in a procedures first approach. Does anyone have any questions about that? I'd like to play the second one, and I think the second one is more with me pretending I'm that student, or perhaps is that enough? You tell me.
I'd like to see more. Personally, I actually get it more when you're showing us a vision.
Okay, so second one is, I think this is me being a student. We'll see. It doesn't matter. Anyway, here we go. Now we can convert between fractions, decimals, and percentages. The rule when converting fractions to percentages is to multiply by 100. So in this case, we multiply 11/12 by 100, cancel down where appropriate, and that's why we end up with 275/3. But that is an improper fraction, and so we do our improper fraction thing, and we end up with 91 2/3%. When converting from fractions to decimals, we simply divide, because this fraction line is also a division symbol. So this really means 3 divided by 4. So when we divide 4 into 3, I'm just going to stop it here, because this is what's going on here is typically what would be taught. And I'd say this is if fractions and decimals and percentages are taught together, then when you've got 3/4 on the whiteboard, you might call that decimal 75, or you call it 75%. When you have 35% written on the board, you call it 0.35. So when you have 20% written on the board, you call it a fifth or 0.2. So you're always just mixing them. It's like 3 languages saying the same thing. That's one thing. But the other thing is, let's just bring some common sense to this. This is using a procedural method, but if we use a conceptual method, so decimals, well, is it easier, students, to think of decimals or percentages? Oh, percentages, sir. Okay. So 3/4. So what's a whole in a percentage? 100%. So what's 3/4 of 100%? Oh, 75. Right. So what's 75 as a decimal? 75% is decimal. Oh, that's 0.75, because they would know that, because you're doing these conversions all the time anyway. So that's my point here, is that this is 100% procedural, and it overcomplicates the task. And work with the decimals appropriately, we end up with 0.75. To convert from percentages to decimals, we simply shift the decimal place 2 spots, either to the left or the right, depending on what we're doing. In the 35% case, we simply call that 0.35, because we shift the decimal place 2 places to the left. When it's 0.4, converting that to a percentage, we shift the decimal place 2 places to the right. And on this point, you see, shifting, is it 2 or 3, sir? Do we shift? Do we go left or right? See, there's no understanding here. It's just trying to remember which way we go. And to me, that's just making it more difficult. Why don't we do it this way? Let's establish that if it's 35%, then whatever you're converting to has got to have 3/5 in it. So we're going to decimals. So it's got to be 3/5. Well, what's 35% roughly? Oh, it's about a third. Well, what's a third as a decimal? Oh, about 0.3. Oh, so it's got to be 0.35. That's a more logical way, but it's using the concepts or an understanding of what's going on. This one here, 0.4 to a percentage. Well, what's 0.4? It's close to a half. So what's a half? It's 50%. So what's it got to be? It's got to be 40%. So that's a more logical, common sense way to go about it. I think that's why it becomes 40%. To convert percentages to fractions, we simply put the percentage over 100, because that's what a percentage is. So 20 over 100 cancelled down becomes 1/5. When we're converting decimals to fractions, we simply need to understand what the place value of the decimal is. And in the first case, decimal 5 means 5/10, and when we cancel that down, we end up with 1/2. And decimal 306 is 306 over 1,000, and we can cancel that down to 153 over 500. Now we can operate with fractions and decimals and percentages as well. In this case, we're using dollars. We could use marbles or staplers or whatever, but we're using dollars because it's sort of more realistic. In this first case, 4/5 of $17, well, we're going to turn this into a fraction multiplication situation. So that's why it becomes 4/5 times 17 over 1, and nothing cancels. So we end up with 68 over 5, which is an improper fraction. So we do our improper fraction thing. So on this one here, I think it's more important that they can estimate, like approximately what's 4/5 of $17, and focus on that. I mean, I'd focus on estimation for a lot of this, once they're starting to work with quantities, and then bring out the calculator and do your estimation first, bring out the calculator, and if it's close, then you're almost guaranteed that you got the right answer. Do you know what I mean? Like this tedious work, I don't even know is that necessary these days. And we end up with 13 3/5 But what's 3/5 of a dollar? Well, let's work out what 3/5 of 100 cents is. And when we cancel down with that 60 cents, so therefore it's $13.60. When we take a percentage of an amount, we turn the percentage into a fraction, which is 30 over 100, and we times by 16 over 1 in this case. Cancel down, we end up with 24/5, which as a mixed number is 4 4/5. When we look at what 4/5 of 100 cents is, we work out it's 80 cents, and that's why it's $4.80. And so that'll be, knowing that 10%, what the 10% are. So 10% of $16 is $1.60, and that, I mean, you do some work on that, so you see the patterns, and so they just know what that is. So we just add $1.60 3 times, and you've got your answer. You know, is a much better way to go, I think, than all this tedium. But to find a decimal of an amount, we just use the multiplication algorithm, but cater for decimals. If there's 2 decimal places in the question, there's 2 decimal places in the answer. And so that's what the answer is, $2.31. You times by 100, you divide the denominator into the numerator, you shift the decimal place 2 places left or right. It just goes on and on and on. So that's that was my attempt at, you know, amplifying the worst aspects of what I would call the procedures first.
We've had a question whether you would mind sharing those videos in the resources.
Sure.
Yeah, great. Thank you. I thought that would be fine. There you go.
Should I just throw, because that's part of an article. I talked this through, and then there's one snippet, and there's.
We'd love the article.
Do you want me to do that now or do it later?
I will do it later. They've got a Dropbox, and the recording and the resources get put in the Dropbox.
Yep. If you okay. Yeah, so I did another one. I was interviewed by someone from 3P Learning over in America, Australia, and she wanted to write an article, but I broke that into about 17 little videos, and I gave, and then in editing I put in some examples. The example I used there was, in that one, was the division of fractions, because it's division of fractions is kind of difficult to, well, it's more difficult to explain conceptually, or to have students, well, it's not that difficult, but okay. Typically, it's not explained. It's like with division of fractions, you invert the second fraction and then you do a multiplication, but it's like, well, why, right? And so I actually gave some examples of how you might handle that. So I did it procedurally first, and then I gave some examples of activities you could do to immerse the students in the concept first. So I think that's a good one to have a look at.
Yes, that would be great. Thank you.
So how are we going here?
Very well. It'd be interesting to see if there are any other questions that you would like to ask of Richard.
Can I just say one thing? You're talking about leadership. I mean, we've only talked about maths here. Yes. Last Tuesday, I interviewed, I'm normally on the other end, I'm normally the interviewer. So I interviewed the principal of the global college in Madrid, an English guy called Barry Cooper, who's just a phenomenal educator. And so he talked about Socratic education and kindness in education, and we'll do a whole lot of other things. So I did a few events like Zoom, like this, events with leaders talking about AI and assessment and using AI and those sorts of pitfalls. But now I've started a series talking to leaders more on just leadership type topics, what makes for a great education, great school, and that sort of thing. And here's one topic I want to get into, and I'm lining up an author, because I want to talk about creativity, and because I think I don't want to get into AI in this session, but I think there's an inference that writing is not going to be as important to teach anymore, because we can now throw in the prompts into ChatGPT and it will write for us. Well, there's a problem with that, because if I'm a hopeless writer, how am I going to know if what it spits out is any good? So I think there's a danger with perhaps creativity and writing and music and art and so on being seen as not so important now, and I think that would be a tragedy. So I'm sort of, I want to shine a light on that. And yes. I've even got a writer lined up just to talk about creativity per se. So if you're subscribed to, I don't know if you're on LinkedIn, but if you are and you're subscribed to the newsletter, then all of those event replays come through the newsletter as well. So,
that's great. And we did put the LinkedIn reference in the chat for you.
Yeah.
So feel free to take that out.
Any specific questions you'd like to throw at me on anything? Well, not anything, but you know, you can ask.
Or any particular challenges you have with teaching maths, primary or secondary?
One thing, okay, well, while you think about that, one thing I will say, so my focus, I have worked with a few New Zealand teachers. It hasn't been a strong focus. I'm happy to, but I am accredited. I am a regionally accredited provider, but because I'm essentially I'm not known here, it's not something I'm putting a lot of energy into. But if you are eligible for regionally accredited PD and you've got some schools and you'd like to have a Zoom chat and explore the possibilities, I'll be more than open to that. One thing I would like to say, and if I may, I just want to spend 2 minutes talking about the style of PD that I've developed over 15 years. And that is, I call it a department-wide approach, or it could be a whole school approach. And I've done this with another consultant. So there's two parts. One is that all the content is in an asynchronous online PD, which involves a lot of self-reflection, a lot of commenting, and a lot of requirement to implement strategies. Because one of the problems with PD typically is you've got this potentially fantastic PD maybe, and the aim is to bring about change in classrooms, but how did you make that change occur? And I see lots of photographs of people in ballrooms, you know, with these wonderful PD days and everyone comes out bright and shiny, but most teachers tell me that, you know, a year down the track, nothing's really changed. So we have this asynchronous model. So it's high quality PD, lots of self-reflection, lots of awareness change, lots of opportunity and requirements to implement strategies into their classrooms over 12 to 18 months. And that's the way you get some change to happen. The other side of it is that we're supporting the team in the school. So it's not, oh, okay, we're just doing this PD and it's all just going to magically happen. No, we're assuming that the leaders in the school want to be involved, and they are an integral part. They're driving the PD, they're driving the implementations, they're, you know, having meetings, show and tell, all that sort of stuff. But it's very flexible. We can build it around what you want. So I'm sort of looking for a school or a cluster of schools who say, look, we've got the ideas and you might have some ideas as well, Richard, but we would love to use that format. And so we can put the stuff together and run something that's not math specific. Well, assuming that one of your outcomes is to raise the level of responsibility that your students are showing in their learning. So, you know, student agency. I have experience with this. I worked with a primary maths consultant, and we built two of these big online courses, and we had a number of cluster of schools go through that. The biggest was the Armidale Catholic Diocese. So there's 750 teachers across 36 schools, all immersed in this one program. So the head of the school, of every school, was involved, and there were school leaders involved in the program. And so the whole thing worked. And the first course was 12 months, and then the second course was another 12 months. So that just, it was just so well set up, and it worked really well. So if that model inspires you and you'd like to have a chat just to explore what's possible, then I'll be more than happy to have a Zoom and explore the possibilities.
Great, thank you. That's excellent.
Sounds great, Richard. So Tracy has a question about what is your take on maths anxiety and how it impacts learners?
Well, any anxiety impacts the learner or the participant negatively and severely. And I would say, well, you know, it's common sense. I'm not an expert on mathematics anxiety, but it's pretty obvious. Sorry, the light's changing here. I think a lot of the stuff that we've talked about explains where the anxiety comes from. You know, exactly. if I'm teaching, here we go. If I'm teaching, if I'm just in a procedures first mindset, and I'm not focused, I'm not even thinking about the concepts that underpin. I'm just like, the kids have got to get that practice, and it's very much sage on the stage. And most of the time, that's what I do. But occasionally, so I can tick off the, have I done some communication this month? Yes, I did, because we had a little half lesson on communication. And have I done some collaboration? Yes, we did a little activity, that month. And that's how I can pat myself on the back that I'm doing those soft skills. But basically, I'm sage on the stage, and the kids are cranking out their procedural practice. Then what are they? They're the inchworms, aren't they? The grasshoppers.
They're grasshoppers, and it will actually be the grasshoppers that actually have anxiety. And I've got them lining up in my specialist teaching tutorials. Some people are actually frozen, like were unable to even do maths, and we're having to get them from that. And it's very much the multisensory, helping them with the understanding, so that they realise they can do this.
And when you get kids like that, and of course they're difficult to deal with. I'm not suggesting, and I don't want this to be interpreted as, oh, Richard's just really negative on maths teachers. No, they are doing the best they can, but like I was for years, a lot of them are shooting themselves in the foot, because they are using strategies that aren't fostering any agency, and they're just making their job more difficult than it needs to be. They don't know what they don't know.
Yes.
But I guess the flip side to a kid with lots of anxiety, is those kids who just rebel and then just become behavior problems.
Another thing that actually happens for those students, I had students who, this was in primary maths, had an assessment, and the student didn't achieve well in the assessment. And I asked for a copy of the assessment. And when I had a look at it, I knew that the student could do a lot of the work. So I reassessed the student orally, and she actually passed 2/3 of the test, actually. And one of the problems was the time, because they've got processing delays, they can't complete the test in the time that's actually allocated. But what transpires then from that is, if you get a student who's got only 1/3 of the test passed, you're going to teach them stuff that they already know. So we need to do things differently.
Well, there's one assessment type that I advocate in a couple of our PDs, and it's called the I Can Do assessment task. So let's say you've got right angled triangle trigonometry, for those of you who remember that. So rather than do the standard, what's the answer to this question, what's the answer to that question, there's 4 questions, and each question starts with, I understand and can do, or can find the length of a side in a right angle triangle. And they make up their own question, they answer their own question, and they explain it. And then there's like 3 or 4 of those sorts of questions. And then there's one that they've got to put it all together in a real world sort of situation. So you have these, I had a He-Man type year 10 kid. He had the birdie in the tree singing to the guy down below, and there's all these triangles. It's hilarious. But you show them this on the data projector at the start of the unit, so the kids realize, oh, geez, okay, so I have to actually understand this. It's not just about making out answers.
Yeah.
And I had these twins that used to get 49 or 50%. Always one was 1% above the other, almost without fail, like for any test. Guess what? How those kids did with these I Can Do assessment tasks? They were right up the top. And I'm thinking, so they do understand. Yeah. And I reckon most of the reason they were like total average 50%ers is because of the anxiety. They just can't do tests.
Yes. Yeah.
It's just those traditional assessment types are just so poor at determining what kids can do.
Yeah. Well, we've covered a few topics today, and thank you very much, Richard, for engaging us and making us think about some of these things. Let's finish up with a couple of things, but while we do, I think people have got their names in the drop box. So would you like to, Madeline, pull the name out of the hat
And the first draw will be for Richard. Would you like to announce the first draw?
That was the freebie, wasn't it?
Yes.
Right. So I need to share my screen. Is that okay if I do that quickly?
Do.
All right. Hang on. Here we go. All right. Boom. If I go over here, so where are we? Here we go. So I've got a bunch of PDs. Most of them are in the hundreds, but there's two $40 ones and three $20 ones. So these are math specific. So you can hand them to a mathematics teacher, except for that one. That's for any kind of person really, or even that one. But these are the two best ones for maths teachers. I think they're great. So you can get one of those for free. You just need to email me, or we'll have to work out how this works. But I'll need the email of the person who's going to do it. So there's no point giving it to someone who doesn't want to do it. But this one's an understanding first approach, just using right-angled trigonometry as an example. And this one is a way to, it's a game changer pedagogy to present equations to any kind of middle school to high school kids. So that's that.
So,
Excellent.
Richard, you say instead of us giving it to one person, if I give you the email address, I've got email addresses. So if any of these people would like one of those programs,
I'd be happy. I'd honestly be happy if any of you have got a maths teacher who would like to do one of those courses on that. I can send you the link to that page. Any ones that are $40 or less, yeah, I'll be happy to give them.
Okay, still draw out
as
a
long
winner
as
for today, though.
the condition. There's a condition that they have to write comments. There's only about 2 or 3 comments required, and they've got to write some feedback. That's the only requirement. So they've actually got to do it, not just kind of flit around like that on their phone, in a bus station or something. They've got to actually do it and give some feedback.
Great. Draw a winner for today, and then that's very generous of you, Richard.
No worries.
Who's the winner?
So Tracy DeWard.
Well done, Tracy. Yay. Excellent. And I know that you'll be a keen recipient of that.
Oh,
and
thank you very much.
And the second draw, a copy of the Wobbly Kids, is coming to
Jenny Bainbridge. Jenny, do you already have a copy? Oh no, you'd like one?
She does. Very good. I'm very happy to send that to you, Jenny. So that's fantastic. Now you've got a couple of things to say to finish up. It's a pleasure. A couple of things to say to finish up, Richard, about your courses online.
Well, I just thought, because I'm in a generous mood, and us Aussies are friendly, generous people, let's face it, most of us anyway. So I've got one other thing here. So, and I also wanted to show you what these look like. If I could get that out of the way, you probably can't. Yeah, right. Where are we? Okay. So this is just courses.learnimplementshare.com. So this is my course academy. So except for this one, which is the international PD, and that's pretty expensive anyway, these other ones, this agency Empower Your Math Students, that's a fantastic PD. That's the single price. That for multiple people it's $5.90. If you click that, you get the information on the whole course. There's a GeoGebra course there, and there's the workshopping of concept-specific open-ended questions. That's a cracker. These are the 40 ones you saw before. There's a number 1 course for early career teachers. There's a coordinate geometry one, and that's pretty much it. So I'm happy if you order for 2 or more people, you get one for free. So it's 2 for 1, or 3 for 2, or 4 for 3. So I'm happy to give you a freebie as long as you buy one. And so again, all I need to know is the teachers. Well, I'd send you an invoice. Don't pay for it on. If you try and pay for it off the button, you'll find that it's in US dollars, right? So last time I checked, the New Zealand dollar is a lot less than the new
yes,
US.
it certainly is.
Well, I'll have to charge you in Australian because it all comes from Australia. So but
no worries.
So you get an invoice there. So you can have. I'll send you the link to that. You can have a look at those courses, and if you've got people who are genuinely interested in that, then you can get a freebie there.
And we'll put the links to the articles that he was talking about, the videos will go in the Dropbox along with the recordings, the recording. So thank you very much for the session today, Richard. It's been great to
Pleasure.
have you. And we'll look forward to hearing how you get on and be connecting again in the future.
Someone just said, are you saying that we can all get some free PD? Yeah, so for that low price one, the 20 or the 40s, yes, if you've got someone who would like to make the
But you have to put a comment, you have to review the course
whoever
after you've
does
done
it,
it.
whoever does the PD has got to do it properly and not
Yes.
just kind of nosy around the edges.
That's
yeah,
a
'cause
very fair deal.
yeah.
Great. Well, we'll look forward to seeing you next time on the forum in the next month. And just a comment that I wanted to make, if anybody here hasn't caught up with that the ministry is offering funded PLD for teacher aides, that's a good thing. Anyone can email me about it if you haven't caught up with that, and I will give you the additional information. So great to see everybody. Thank you for your attendance, and we'll see you next time.
Yeah, last plug, if anyone wants to have a chat with me about exploring the potential for doing some regionally allocated PD, just we'll
got the
have contact details
LinkedIn, and we'll
too.
make sure that you get connected. You can even email me, and I'll make sure it goes through. Great.
Thanks everyone.
See you. Bye-bye.
Bye.